Okay, students, you already saw a brief introduction to proving triangles similar on your homework last night. So, I apologize for the way I sound, but I'm going to try to help you with how can you prove something else, not just prove triangles similar. So, the whole idea is to do a very similar process to what we did with congruent triangles, where we were proving triangles congruent, and then we had that lovely shortcut that you may remember, that we usually wrote as CPCTC, and that's going to come up again, except for that stood for corresponding parts of congruent triangles are congruent, and we're no longer talking about congruent triangles, we're talking about similar triangles. So I can definitely tell you that this C is going to become an S. And then the other question we have to ask ourselves is, are all parts of similar triangles congruent? And by parts I mean angles and sides. So if we go back to our definition of similar triangles, we know that corresponding angles are congruent. So if we consider this P right here to be an angle, one of my three angle pairs in my triangles, then I can say they're congruent. But if those are sides, corresponding sides in similar triangles aren't congruent. They're actually proportional. So that's going to take on two forms. I mean, it's really the only difference with these, but I did want to give you some examples. So I'm going to say that this guy is going to become corresponding angles in similar triangles are congruent, or corresponding sides in similar triangles are proportional, depending on which one you're saying at the end. So if we take a look at our proof, you might be able to understand where I'm going with this. Except the first one, we're really not proving angles or anything about angles or sides. But I think we've done enough parallel line proofs that you know that if you have angles congruent, then you can get to lines parallel. If I were in class, I would pause right now and tell you to prove triangles similar in number 1. So I'm not going to take the time right now to do it, but I would encourage you to pause the video and go ahead and see if you can prove triangles similar, even though that's not what the proof says. So ignore the proof and see if you can prove triangles similar. Okay, I'm glad that you were successful with proving triangles similar, or you feel like it. Let's double check and see how you did. And let's stop right there. I'm going to do a quick little erase so that you can hopefully see what I wrote there. I apologize for my sloppy writing. So it looks like we said AX over XC equals BX over XD was given. And if we take a look at that right here, we got to get used to that. That looks very different. If I ask you what that was, let's pretend there's numbers there, and I'm hoping that you'd say that's a proportion. Have we ever had a proportion in proofs before? No, definitely not. But we have a proportion because we need to show that corresponding sides in similar triangles are proportional. It's one of my ways of establishing that triangles are similar. So this actually counts for an S and an S if you're thinking about your shortcuts. A little bit trickier than what you did yesterday, where you were just using angle-angle shortcut. Notice my shortcut ends up being my side-angle-side similarity because I'm able to establish that the angles between the included angles are congruent because those are vertical angles. The other thing I'm going to point out here is that you need to make sure that your similarity statement is in the correct order. Just like with congruence, we need to match up corresponding parts. So the first triangle I can name however I want. You didn't have to have the same as me. I did triangle AXB. When I get to my next triangle, AX has to match up with whatever corresponding side, whatever side is corresponding with it. So you got to go back to this given information, and you're told that AX and XC are corresponding sides. So you're going to go ahead and put those two letters first, and that's how we're going to determine what the correct order is for our proofs. Okay, so how do I actually establish that lines are parallel? Well, assuming that we can say a pair of angles is congruent, I'm hoping that you're seeing, I already marked it in my picture, so I don't actually know yet that angle A is congruent to angle C. That wasn't in the given information. But now that I know triangles are similar, now we can go back to this guy here. And basically, it's our definition of similarity, that if angles are, apparently I shouldn't write on this, sorry guys for the delay. If corresponding angles are congruent, then if alternate interior angles are congruent, then lines are parallel. So I'm first going to say that alternate interior angles are congruent, but I'm not going to mention their alternate interior. I'm just saying angle A is congruent to angle C, because all angles in similar triangles are congruent, or that's my corresponding angles in similar triangles are congruent shortcut that I was just talking about there. My new CPCTC. And then the final step, this is going to look very familiar. AB is parallel to CD. Alternate interior angles, converse theorem. Pause a moment. Talk to somebody in your group. If you're confused, make sure you understand what just happened. And then join me for proof number 2. I hope it's loading on your page. It's a little blurry at first, and then it comes into focus. So be patient. And like I said, I hope that you're able to see and read what I'm writing. So number 2, I'm going to say the same thing. Why don't you go ahead and prove triangles similar to each other? Be careful with matching up correct parts here. You might even want to redraw those triangles. So take a minute and go ahead and prove triangles similar, then join me. Okay, I'm glad you paused the video and proved triangles similar, because that's good practice, and that's half of what you're practicing today. All we're going to do is add 1 or 2 steps. So here's what I had. Given information is already marked there, and then the other angle pair that's congruent is angle A is congruent to itself. My good old reflexive property, showing up a little bit different than I've used it in the past, but there it is, saying those 2 angles are congruent. That allows me to establish that triangle AXY is similar to triangle ACB. Notice my order there. AXY matches up with ACB, because this angle X has to match up with angle C. So if I put X, I had to put C, and that looks weird. We also could have them lined up sort of that you just slide one apart, but it actually requires a reflection to get from one to the other. And there's my angle-angle similarity postulate. From there, I'm going to try to prove that AX over AC equals XY over BC. And again, I'd ask you, what is that? And hopefully you're going to say that's a proportion. Well, what do we know about corresponding sides in similar triangles? They're proportional. So that is my next step. And all I have to do is write it down and recognize that that is saying that sides are proportional. You'll never have one fraction by itself. It's always a fraction equals a fraction results in proportional sides. So there's my, one more time, if you didn't catch it. There's my corresponding sides in similar triangles are proportional. My second version of CPCTC for similar triangles. Okay, looks like you guys are doing great. Let's go ahead and go to number 3, which may say number 3 and may say number 8 on your paper. Whatever it is, it's the next one down there. And I'm going to change one thing from what I have, and I'm going to prove what's actually on your paper. So let's go ahead and do the same thing. Pause, go ahead and prove triangles similar, and then I will join you, and we'll go over how do we prove this random statement that the product of 2 lengths is equal to the product of 2 other lengths. This one's a little weird. Okay, I'm glad that you were able to prove triangles similar. Let's see how you did. Maybe you had something like this. So similar picture to the last one. This one might suit you a little bit better. You might like it, the way the triangles are oriented. I apologize for my sloppiness. I'm trying to make this efficient and not do a 25-minute video. This symbol right here, just to make sure we're all on the same page, that should be just the squiggle. Is how we show similar. Triangle similar to another triangle. It's like the congruence, except we take the congruence, the equal part off, and we're just left with the, we're just left with the similarity squiggle, which apparently won't let me erase. We're just left with that. Okay, so now this one we have to prove that the product of 2 lengths is equal to the product of 2 other lengths. So I don't know how we're going to do that, but I do know that we're talking about segments in triangles, sides, and we know that sides in triangles, corresponding sides, are proportional. So what proportion could we make that would use the lengths that are written here? I'm just going to see if I can make a proportion and then see what happens. So I'm going to propose that I could make a proportion by, let's see, if I take AY, that matches up with, so I just used AY. I'm just trying to figure out what I've used here. That matches up with AC in my larger triangle. Those would be corresponding sides. And if I'm able to prove triangles similar, which I did in step 3, then that would be true, that would be equal to, let's make another ratio. So I just used AC also. Can I use, let's see, a XY or BC? Well, XY is in my smaller triangle, so that would be equal to the ratio of XY over BC is in my bigger triangle. Pause and make sure you can agree with that. Because I'm thinking that by corresponding sides of similar triangles are proportional, CSSTP, I can establish that statement. And if I can say that, okay, well now let's look at this craziness here. Can you agree with that statement? Well, what would happen if I took this proportion that I have and I multiply by AC on both sides? On the right, I get AC times XY, which is the same thing as I have here. On the left, AC cancels out. And then what happens if I actually multiply by BC on both sides? So let's grab another color. And if I multiply times BC on both sides, well, there it's going to cancel out. But if I multiply by BC, I end up with AY times BC equals XY times AC, which is what I was going after. The rest of everything is gone. So could we say we just used our multiplication property? Didn't we just multiply on both sides? Cool. So that's going to look something like this in my proof. And I'm going to modify that last reason. I don't actually like what I wrote down. So I'm going to change that. And I'm going to say instead of a property of proportions, let's go ahead and write MPO. Multiplication property of equality is really what we use there. Let's keep it simple and use stuff that we've already established. Thanks for watching. I hope I hope that helped you to understand how to use similarity in proofs.